This question is from K 2022 Mechanical Engineering paper set 2, question number 47. The lengths of members BC and CE in the frame shown in the figure are equal. All the members are rigid and lightweight, and the friction at the joints is negligible. Two forces of magnitude Q greater than 0 are applied as shown, each at the mid length of the respective member on which it acts. Which one or more of the following members do not carry any load or force? Let's find out. Now, this given structure has load acting at locations other than the joints, and therefore this is not a truss but it's a frame. Now, in this frame, we can see that when Q acts on member CE, definitely there will be load at joint C, which will be distributed to the members CD and CB, as well as at joint E, which will be distributed to EF and EB or BE. Now, the load that is coming on BE, when it is being transferred to joint G, the direction in which this load will be transferred will depend upon the constraints at joint G. Now we can see that at joint G, movement along the member BE is unrestrained. That is, joint G can move along this direction. So whenever a joint allows movement of the member resting on it in such direction, the reaction that is offered by the joint is always in the direction perpendicular to the movement. So reaction is offered in this direction, and therefore in this case we can see that reaction will be offered in this direction. Now joint H is a joint where only rotation is allowed. Rotation is unrestrained, and therefore it is going to offer reactions in horizontal as well as vertical direction. So if we draw a free body diagram of this member GH, we will have, this is that reaction force which joint G is offering. Let this be reaction at G, RG, and these will be the horizontal reaction at H. Let this be HX, and this will be the vertical reaction at H. Let this be HY. I have assumed it to be downward. You can assume whatever direction you want to, because at the end we will get the correct direction. Now here, if we apply the equilibrium equation, which is summation of moment about joint H is 0, as it is free to rotate, the summation of moment or net moment at joint H will be 0. We can clearly see that the only component that will create a moment about H is Rg. So if we take the horizontal and vertical components of this reaction, RGH, that is horizontal component of Rg, is going to be resisted by this Hx, and this vertical component is only going to create a moment, which is Rgv. So we can write the equation here, Rgv into length of member GH, let it be LGH. This will be clearly equal to 0 because there is no other force here, and therefore we see that Rgv will be equal to 0. So if there is no reaction offered by joint G, no force will be transferred into this member GH, and hence force in member GH is 0. Now that we have identified that the force in member GH is 0, we can remove that member altogether, as well as the support at point H, and the structure will look like this. Now we need to find out if there is any other 0 member in the structure left. For that, we'll first find out the reactions at the supports. Let the support reactions be DH and DV at support D, FH and FV at support F, and AH and AV at support A. Now the first thing that we know is, by joint equilibrium, for the stability of a particular joint, the summation of all forces in x direction should equate to 0, as well as the summation of all forces in y direction should equate to 0. So at joint D, we can say that the horizontal force DH will be 0 because there is no other horizontal force at support D, and the vertical force dV will be exactly equal to the force in member CD. Similarly, the support reactions AV and the support reaction FH will also be 0. Knowing this, we'll proceed to find out the other reactions. So let me just cancel out the reactions that are 0. DH is 0, FH is 0, and AV is 0. We are left with three unknowns, DV, FV and AH. and we have three equations of equilibrium. For the complete structure, we know that summation of all forces in x direction should be 0, summation of all forces in y direction should be 0, and summation of moment about any support will be 0. So if we choose the support F, net bending moment acting at support F should be 0. Using these three equations, we'll find out these reactions and then find out the force in members, thereby getting the zero force member. Let's do that. So first thing, using summation Fx equal to 0, we know that the only horizontal reaction in this structure is AH, and the external load acting Q is also horizontal. So plus Q. Both are in the rightward direction. Notice that I have assumed all the reactions to be positive first. We'll get the sign as and when we calculate them. So AH plus Q will be 0, and therefore we will get AH here should be equal to minus Q. Let this be equation 1. We have the value of AH with us. Second thing, by summation Fy equal to 0, we can write down the upward forces dV and Fv will add up. So dV plus Fv, and the downward force Q will be negative. So minus Q equal to 0. This will give us dV plus Fv is equal to Q. Let this be equation 2. Now we have two unknowns left, and this is the one equation we have formed already. We have another equilibrium equation left, which is the moment equilibrium. So let's use that. We have summation of moment about point F should be 0. Let's take the moment about point F. So this reaction force dV into the length L will create clockwise moment. Let's take anti-clockwise positive. So it will be minus dV into L. Then this downward force Q will form anti-clockwise moment about point F. So it will be positive. We have plus Q into L by 2. Then we have this rightward force Q again forming anti-clockwise moment. So we have plus Q into L by 2. And AH here is going to form a clockwise moment because we have determined that it is negative of Q. So it should be towards the left. So it's going to form clockwise moment about point F. We have minus Q into L. This will be equal to 0. Don't get confused here. AH into L is the moment and AH value is minus Q. So we have the moment as minus Q into L. Simplifying this, we will get force dV is equal to 0. So we are directly getting that reaction dV is 0, and therefore by joint equilibrium equation at joint D, we will have force in member CD should also be equal to 0, because we have already found out that dV is equal to force in member CD. So as dV is 0, force in member CD is also 0. We have another zero force member, which is CD. Now apart from CD, we know that the members CE, BC, BE should be non-zero force members because these loads Q in the vertical and horizontal directions are directly acting on these members. Therefore, these members should be having some force in them, having some non-zero force in them. Also, member AB and member FE, AB and FE should also be non-zero force members because AH is non-zero as well as FV is non-zero. So previously we had GH as a zero force member, and now we have the member CD as a zero force member. Our answer is the zero force members in given structures for the given set of loading are GH and CD. So let's go back and mark the options. Answers are options B, CD, and option D, GH. To learn more about structural analysis, you can refer to the NPTEL video Module 1 Lecture 1 Review of Basic Structural Analysis 1. It is from the course Advanced Structural Analysis. The course is taught by Professor Devdas Menon. He is a chair professor in IIT Madras. I hope this solution helps you clear your doubt. Thank you.